Welcome! Today we are diving into something really powerful for any organization with a modern, spread-out network, the Cisco SD-Access Distributed Campus. We're going to break down how this thing takes all these separate network islands and, well, magically unifies them into a single, automated fabric that's all driven by policy. It's pretty cool stuff.
So here's our game plan. First, we're going to lay out the big challenge with multi-site networks. Then we'll introduce the automated solution and what makes it tick. After that, we'll dive into how you actually connect these sites, trace a single packet's journey from end to end, and then wrap it all up with why this approach is such a big deal.
All right, first things first. To really get why this solution is so important, you have to understand the problem it's solving. And it's a problem that tons of organizations are dealing with as their campuses get more and more spread out. This image right here, it perfectly sums up the challenge. You've got these independent fabric sites. Maybe they're in different buildings, maybe even across town, and each one is basically its own little network island. The million-dollar question is, how do you get them all to talk to each other like they're one big, cohesive, and, most importantly, secure network? You know, the old way of connecting these sites was, well, it was a major headache. It was all about manually stitching things together. That meant packets had to be constantly unwrapped and rewrapped at every border. You needed all these extra protocols and super complex mappings just to try and keep your security policies consistent. Honestly, it was a mess that just couldn't scale. So now for the fun part. Let's look at the solution Cisco came up with to fix this exact problem. And it's a solution that completely flips the script from manual complexity to automated simplicity. At its heart, this whole solution is about taking the power of the fabric, all that automation, segmentation, and security, and stretching it out over a huge geographical area. It makes sure that your security policies, things like your virtual routing and forwarding instances, or VRFs, and your security group tags, or SGTs, are just automatically there, everywhere, no manual work needed. This slide really brings it all home. Just look at the contrast. We're getting rid of all that manual policy grunt work. We're ditching extra protocols like SXP. But the most important piece, the real game changer, is that we keep a single VXLAN encapsulation from the source user all the way to the destination. This means the packet security and its network context literally travels with it. That's the secret to making policy automation work end-to-end. So what's the magic that makes this all possible? Well, it really boils down to two core technologies. Think of Lisp as the network's GPS. It separates who a device is from where it is, so it can move anywhere. And VXLAN? That's like the specialized shipping container that wraps up the data packet, along with all its security tags, so it can travel safely across the network. Okay, before we start connecting all these network islands together, we really need to understand what's on each island. So let's take a look at the fundamental building blocks that make up a single fabric site. This table is actually super useful. The source material gives us these really practical guidelines for thinking about site sizes. For a really small site, you might just have a fabric in a box, where everything runs on one device. But as you scale up to small, medium, and large sites, you start to separate out those roles, like the border and the control plane, onto their own dedicated heavy-duty devices to handle way more users, networks, and traffic. And this is what a typical site looks like from an architectural view. You've got your edge nodes, which is where all your users and devices plug in. You have a border node, that's your gateway to the outside world. And then you have the control plane node, which is basically the brain of that local site. The key thing is, each site is its own little self-sufficient world. Okay, so we've got our independent, fully functional sites. Now for the big question, right? How do we build that super highway that connects them all and lets traffic just flow seamlessly between them? Turns out you've got three main choices for this transit network that links your sites. You could use a classic IP-based network, you could use an SD-WAN overlay, or you can use the native SD-Access transit. For our purposes, we're really going to focus on comparing that old IP-based method with the new SD-Access method, because that's where you really see the innovation. This side-by-side really says it all, doesn't it? Look at the left. That's the old IP transit way. The VXLAN fabric just stops dead at the site border. The packet gets unwrapped, loses all its special context. But now look at the right. With SD-Access Transit, that VXLAN encapsulation stays on end-to-end. The data plane, the policy plane, it just stretches right across the transit network, creating one giant unified fabric. This is a brilliant analogy from the source material. To manage this whole multi-site world, we introduce a new piece called the transit control plane. But, and this is key, it's not actually in the data path. It works just like a DNS server for the whole fabric. It tells the border nodes where to find endpoints in other sites, but it never becomes a bottleneck for the actual traffic. It's really clever.
Okay, let's put all the pieces together. I think the best way to really understand how this works is to just follow a single packet on its journey, all the way from a computer in Site 1 to a computer in Site 2.
So our journey starts off pretty simple. Host 1, which is plugged to an edge switch over in Site 1, just sends a normal data packet. It's addressed to host 2, which it knows is out there on the network somewhere.
Okay, so the edge switch gets the packet, but it checks its local cache and has no idea where host 2 is. So it does what it's supposed to do. It sends out a Lisp map request. It's basically asking its local boss, the site's control plane node, hey, you got an address for host 2?
The local control plane checks its database and realizes that host 2 isn't registered anywhere inside Site 1. So it sends back what's called a negative map reply. And that reply basically says, look, I don't know exactly where it is, but I know it's not here. So just forward the packet to our exit ramp, the border node.
So now, the edge node has its instructions. It takes that original packet from host 1, wraps it up in a nice VXLAN header that's got all the policy and segmentation info baked in, and sends it across the network to the site's border node.
The packet has now made it to the very edge of its local island. Now it's the border node's job to find the destination island. And to do that, it sends out its own Lisp map request. But this time, it's not asking its local boss. It's asking the big boss, that master directory for the whole network, the transit control plane. And that's the final piece of the puzzle. The transit control plane knows that host 2 lives in Site 2, so it replies with the address of Site 2's border node. The border node in Site 1 now knows exactly where to send the packet. It forwards that fully encapsulated VXLAN packet across the transit network, and when it arrives at Site 2, it gets delivered to host 2 with all of its original security policies perfectly intact. The journey is complete.
So now that we've seen that whole automated process in action, let's just zoom out for a second and recap the huge benefits that an architecture like this really brings to the table.
At the end of the day, this is all about making your network easier to manage, way more secure, and ready to scale. You get automation that gets rid of all those tedious, error-prone tasks. You get security policies that actually follow the user no matter what building they're in. Your day-to-day operations get a whole lot simpler, and you've got a solid framework for adding new sites whenever you need to.
So we'll just leave you with that one thought to chew on. In a world where our workplaces are more distributed than ever and security is absolutely critical, is hanging on to those old manual ways of managing a network really a sustainable strategy for the long haul? Thanks for joining this deep dive into the SD-Access Distributed Campus. We'll see you in the next Explain.